Everyone, I'm Michie and I'm from WWCode Manila. How big the impact the community is doing. Being confident to speak at tech events, conferences, and more. Being able to contribute to open source, being able to become leaders in their company, or being able to just voice out and change whatever is necessary to change. Having that community where you can just share your love and passion with technology without being discriminated or being judged is such a good feeling, right?
Hi everybody, I'm Mamta Gilani, basically the director of Women Who Code Lanterns. As being a part of Women Who Code Lanterns gives visibility to my profile to the wider audience, so you can have like constructive feedback on whatever things you are doing. So empowering the woman in a way you are empowering the society, which unlocks basically the power and potential of each individual. We can rise, we can shine, but I cannot do it alone. But as a part of a community, we can.
Hi everyone, my name is Purnima Kamath and I am a director with Women Who Code in Singapore. Building the Singapore network has given me the opportunity to build on my leadership skills. For me, the opportunity was in testing and honing my leadership style, which I could apply back to my job to be a better technology lead and a manager. The Women Who Code brand and the startup-like environment has helped me build an entrepreneurial mindset, all the while making a considerable impact and giving back to the community. I am proud to be a part of this organization and I wish you an amazing Connect India 2020. Stay safe.
Hi, my name is Shih. I am the Senior Director of Women Who Code Taipei. In the beginning of this year, we were able to connect with VMware leadership team and was able to develop the Cloud Community Coach program that can be implemented in Taiwan, especially in Women Who Code Taipei, with the help with Women Who Code Bangalore team. We are very grateful to have this program implemented, and we will continue to rock it in Taiwan. We know that there will be a big conference coming for Women Who Code Bangalore team, which is called Women Who Code CONNECT India. We hope everything will go well, and we are excited to join from Taiwan. Thank you.
Hello, I'm here to talk about the impact Women Who Code has had on my life. Women Who Code is very near and dear to my heart. It's given me a safe space where I can be myself and overcome my fears in a very judgment-free environment. My fears being public speaking for one among many others. It's given me a space where I can get to know myself, and that's helped motivated me to contribute back to the community.
Hi, good morning, and a warm welcome to Women Who Code Connect India 2020. This is a premier developer conference which brings speakers across the globe to share their deep technical expertise and inspiring stories of success. This is the fourth Connect conference. The theme of this conference is Innovate Today for a Better Tomorrow. It's a great pleasure and honor to be one of the hosts. I'm Padmini, a volunteer at Women Who Code, and I'm also an R&D manager at VMware. We have a gamut of interesting things lined up today. In the technical track, we have some deep technical discussions on some of the most happening and relevant technologies. The speakers are well-respected leaders and masters of their craft. Also, we have business leaders, the decision makers, CIOs joining us and share their take on the evolution of IT industries in these trying times. We also have pioneers who will share their inspiring stories and passion to excel and professional excellence. I'm sure there is a lot of learnings, insights, and loads of inspiration for all of us to take from these. So let's get started. The first session today is the keynote session. Today's keynote is about making an innovation stick and tick. It's about making innovations last long and making the lasting innovations profitable. This needs the right mix of deep technical expertise, a great understanding of market dynamics, and an ability to apply different perspectives. To talk more on this, please welcome Lily Chang, Vice President, Strategic Transformation Office at VMware. Lily, if you could come up, please. Named as one of the top 40 powerful women engineers of 2018 by Business Insider, Lily today leads Strategic Transformation Office at VMware. Lily is a technology and business executive with extensive experience in cloud, enterprise, semiconductor, and embedded industries in the area of portfolio, product management, strategic planning, product development, engineering, and global operations. Just to give you a feel of her technical expertise, Lily has built and worked on 24 compilers and debuggers. Isn't that amazing? She has worked with some of the titans of this industry, be it with the founder of C++ or with the founder of BSD. Besides the technical and the leadership roles that she dons, she is also a board member of Women Who Code and an Ikebana teacher. So let's see how to put together compilers and Ikebana. Over to you, Lily.
Thank you. It's a great pleasure to be able to join this today. This is a fantastic event and also a very impactful one. When I was basically suggested to come and basically give a talk regarding the innovation, and I started thinking about what will be the right focus message that I can actually offer. If you look at my career, right, I am really not one of those technologists that has boatload of the patents and stack of certificates and titles, basically about innovation. However, I take a very strong pride in helping a lot of the industry technologists and especially the giants in the technology revolutionary area, such as the creator and the designer of C++, Bjarne Stroustrup. I work with him very closely, shoulder by shoulder. I debug his code. I work on the standards. And basically, he is one of my lifetime mentor as well. Also had a pleasure to basically be exposed to a lot of the early innovation technologies in the programming language, such as the Java, the Ada, and also the Berkeley Unix. So based on this, I reflect on what I can actually share today with everybody. Innovation is a constant factor in the technology field. And to make it just works and to make it sticky is actually a very major challenge. So basically, today, what I really want to be able to communicate is a couple key messages. One of the basic things that before we even start to talk about innovation, innovation has a characteristic. Innovation fundamentally is messy. And one of the things that scientists has done is they basically measure basically two groups of people. One group of people that work in a very messy room, and then another group of people that work on a very clean, organized room. And they both were told to basically innovate and be creative. And then after a while, they take a look at the innovation outcome. It turns out the people that and the team that's living in the messy room has roughly in average, based on the empirical analysis, about 28% more creative. And so does that mean that you only need to be innovate in a messy room? That's not what I'm saying here. What I'm really saying is innovation is messy. Innovation is fundamentally, inherently packed with changes, unknown, unexpected. The characteristic is the expectation is you are going into an innovation zone to discover and to experience, right? Many times in the innovation, a lot of times it's not just you're having a vision, having basically a notion, a great idea. A lot of times the key is actually the devil is in the detail. And very often innovation cannot be innovating all by yourself. And a lot of times you will end up working with the user, the customers, and a team of people and a group of experts. And in those particular cases, what really happened is there is a lot of the storming, a lot of the alignment, and sharing the perspective. Just like basically, if you look at this picture on the screen here, do you see an older woman or do you see a young lady with a feather of a beautiful hairdo? It is a matter of the perspective. It's actually both, right? And the key here is in the innovation in the beginning, a lot of times is messiness is the dominance. So the key is to embrace this particular messy situation. So let me come back and then talk about what will make innovation really work, right? I will share two personal experience. I am an Ikebana teacher. It took me actually 10 years to get an Ikebana teacher degree. And also on the other side, you actually see a little robot. And this robot actually is quite famous. And you see a little child that's basically dancing with the robot. This is basically the educational learning robot that basically work with autistic children to help them to basically be ready to learn and be able to focus. So why am I talking about the robotic stuff? Because I personally have a very strong interest in terms of human-machine interaction and artificial intelligence and machine learning. So I have funded a research award program with one of the ACM and also UMU-AI, which focus on AI and ML. And basically that award program reward the young researcher that has revolutionary thinking and the concept and the research results. And I've been funding this for a little bit more than 12, 15 years. And recently I attended one of their conference in the award ceremony, and I learned something and I want to be able to share with you because it helped me to understand a very key aspect of how to make innovation successful. Let me first talk about the Ikebana. Why would Ikebana has anything to do with technology? You can look at these four different, very different Ikebana design. and the arrangement. And basically the upper side, there is a very large arrangement that takes the whole space of a room. And then the other three are pretty much you can put on the desktop. And they have different material. That's the seemingly difference among these four. The key point I want to actually emphasize is the school that I took. It took me about 10 years to become Ikebana teacher. Is basically has an architecture for all these four design. Basically, they follow simple 7 steps. Each of the steps represent a concept to spark your imagination. And it talks about heaven, earth, yourself, your parents, your sibling, and the Buddha. And basically, these 7 steps form the architecture platform. And that's the structure and the dimension. And then the rest is basically in the artist's imagination in terms of the material that's available to the artist to use. And the most important thing is the artist usually, before you arrange it, it's not following the rule book and then you'll be done with a beautiful job. You have to imagine with the material what will be the end state and what does it done really means. And that's with the material on hand. So the key point I want to emphasize here is all these 4 arrangements are done with the same 7 step, nothing more complicated than that. And then the most important success factor is the imagination of the artist of the eventual state and the vision of how material fit into that eventual state. So the key word here is imagination and whatever is available to you, right? And the platform is very robust. Now, let's come back and talk about more the system and the software aspect. And this is a very famous robotic project. And it is called Cognitive Robot, and it is a form of education robots. More than 5,000 parts, and each part is a very intelligent component or module. And each robot, actually, the current running cost, it takes about $250,000 US to build. And there's roughly about a couple hundred of them right now. Now, this particular project is started by a very famous professor that's in the Institute of Technology in Italy. And this project is called iCup. So you can see the robot is actually trying to basically play with the simple movements, and then it basically had the arm and the focus of the eye is actually a very important part. Now, the robot basically it's basically something that is not a very brand new science. For example, all the software is written basically using C++ and is on standard Linux BSD platform and basically use all the typical programming techniques. There's nothing revolutionary about that. And that's one of the key points that I want you to bear in mind. Technology today in computer science is very robust. When you work on the ML or the AI, the database system hasn't been changing in terms of fundamental concepts since 10, 20 years ago. 20 years ago, we had the pleasure of creating something called the relational database. Ingres was really the pioneer for that. Today, we still use a very similar technique. And the really difference here is the materialization and the embodiment of all these technology combined together into this cognitive robots, right? And this professor was giving the keynote in this particular UMU AI and the Human Machine Interface Conference. And basically he talked about the progress he made on the iCup. And during the Q&A, one of the audience member asked the professor and said, you know, you've been working on this for about a decade. Can you tell me what's the most dominant use case? And the professor says, basically, the most dominant empirical success use case is actually these robots can use to help autistic learners. Doesn't matter it's children or adult or any age span. Basically, it helps the autistic learner to be able to focus, to be able to basically follow the repetitive motions and be able to communicate with the robot and then get the environment all proper for the learner to be ready. Now, with that said, does it really take $250,000, a robot, to really help autistic learners and in these special education? The reality is the Apple iPad has been there for close to a decade as well, being the most dominant vehicle to help basically the speech pathologist, the education people, the occupation therapist, and the early childhood development scientist and the professional to basically be able to help a lot of the autistic children to be able to learn about how they can actually learn about the social interaction or learn just about the knowledge, right? So iPad is definitely a very robust platform and it's been there for a long time. So what is the key point here? The key point here is the knowledge, the technology we have today is very abundant and it has been proven and mature for a while. So it becomes a very robust platform for us to use. The key is really the use case and the application. And the key is the imagination is how do you actually use these technology in order to basically spark basically the contribution. So the use case then is really the most important thing. Then how do you have that killer use case? How do you make sure the killer use case really stick, right? The key thing here is I want to pass on two tips or two success tips. One is do not underestimate the power of dabbling and do not underestimate the power of innovation by experiment. The example I will use here is actually Java. So this graph here shows basically a programming statistics. And this statistic is compiled based on people in terms of how they search for these programming languages. And this is basically across all the popular search engine outcome. And you can see that Java for years, since 2002, has remained being the number one. But let's just step back and talk about a little bit of a Java's history, right? For some of you that are familiar with the Java, Java started back in 1991, back in 20th century. So Java didn't get created in 21st century. It got created in 20th century, more than 20 years ago. And the very first Java incarnation is actually not called Java. It was actually called Oak. So James Gosling is the creator, and James actually has an office that faces the beautiful sunshine and the beautiful windows, and he can see a lot of the green. And there is a beautiful oak tree outside. So when he was working on the Java project, he looked at that oak tree all the time. So that's the reason why the initial name is called Oak. And the initial use case actually is not today's use case. The initial use case was James' vision was he wants this to be applied for interactive TV. And then it didn't really kind of quite work out because back in those days, the cable high definition really was at the immature stage. It cannot, James was, the Java or the Oak was a little bit of ahead of his time. So basically, however, the innovation continued, right? And then the brief interim state is the Oak project was renamed to be called Green. And then basically 1994 and 1995, Kim Palesi, who is actually a great entrepreneur, she has been one of the most influential woman entrepreneur and the CEO. And she was the very first Java product manager. And she got this mission to basically say, now we rename the green to be Java, and it's really the coffee bean. And basically the key is what is the killer use case that will spark the interest of the people? And Kim's idea was basically, let's go for simple easy and people that can basically have imagination when they play with Java or program in Java. So the key use case was animations on the web. And then the other thing that they focused on was they made Java an open platform. So today, that's the reason why a lot of the Java, JVM, all these are available for people. And they spend a huge amount of energy to do a reinvention and retrofitting in order to make sure the interfaces and API are available. So looking back into this year, 2020, back into 1994's decision, there are 3 success factors that made Java really stick. One is the original aspirational use case, which is animation coupled with Web 2.0 at that time. And then the making it an open platform, make it available, easily accessible, and also has very good interface API for people to use. So a lot of this is the success of the Java is simply the Java team start from old to green to Java. Basically, you can say they were doing dabbling, but the reality is they were innovation by experiment, right? So then you say, well, not everybody is a James Gosling, right? The reality is we all have a little bit of a James Gosling in us. What the key I want to advise everybody is you are your own operating system and you control your destiny and you control your time. So one of the things is you need to give the time of dabbling, because dabbling is the easiest way to basically do innovation by experiment. So this picture here shows wonderful people that basically are just basically getting together to do the hackathon. And Women Who Code does a lot of the hackathon. Hackathon is basically the easiest approach where if you just got something in your gut, you want to basically experiment and try it out, that is the easiest forum, right? And the key is you have to give it a priority, you have to give it a time versus saying I'm busy with a whole bunch of other things. The second tip that I want to really pass on is nowadays people brand it as reverse mentoring. And I want to emphasize, besides reverse mentoring, which really emphasize that basically there is no age boundary in terms of who is mentoring who, right? There is only the difference of you are the subject matter expert in the healthcare. I am the subject matter expert of the software coding. So I want to work with you because I want to understand what is the trade secrets and what is the challenge and how do you do your job? How do I make my software to make you successful? So a lot of this is the reverse mentoring or the mutual mentoring, right? And one of the things I want to share with you is one of my recent project, which is a very complicated project. Actually is on its 4th year. And this particular project, we basically want to do what people in business world will call the hyper automation, which is a very, very strong popular trend in the digital transformation world. So what this project has is actually, when it comes down to actual estimation of the coding and the testing, it's actually not that big. For those of you that are familiar with the Agile Scrum methodology, the estimation I got from the software team is that it probably would just be done in about 4 or 5 sprints. But it does take a lot of work from many different functional areas. And I'm a person that understands the R&D. I have decades of R&D experience, but I don't quite understand the finance and the accounting and the business rules and the tricky part of that. And I have an analyst in my group, and so she doesn't understand software. She cannot code to save her life. I cannot do the finance and the accounting to save my life. So what we decided to do is we actually did the reverse mentoring. And I basically, in order to make sure I can actually come up with the right business requirement, I've tagged teamed with her. She taught me wonderful stuff about finance, which was completely instrumental in helping me to make this hyper automation and the robotic process automation actually be a success. So this is one story I do want to share with everybody, that a lot of times The mentoring is not limited by domain, it's not limited by generations or age or profession. So the final tip I want to offer to everybody is dream big and think small. And part of the reason is you always have this beautiful vision, you want to get it done, but the problem is there is not a whole lot of budget available, right? And especially in COVID-19 years, people are tightening the belt and a lot of the innovation basically got put on hold. And one of the things that we know from the innovator dilemma is innovation has to be continuous. If you're innovating for 5-6 years and all of a sudden you just arbitrarily stopped for 2 years and you want to come back in, that ramp time is actually phenomenal and exponential. So basically innovation is very important. Doesn't matter is big or small, you have to basically keep it continuous. So a lot of times the vision can change based on your learning. So it's very important to dream big, because if you can imagine it, you can achieve it. If you can dream it, it definitely, you will become that dream. The key is to realize the vision, the imagination, and the dream has many, many steps. Each step you will learn a lot. So you may want to consider to think small from the execution and the delivery point of view. So here, this is where I want to share with you the learning I have learned from Bjarne Strustrup. So when Bjarne started doing the C++, and I worked closely with him, he was in the Bell Lab, I was in the Sun Microsystem. I released the very first Sun C++. I told my boss, and my second line manager was Eric Schmitz at that time. And basically I said, this is a short and sweet project. It would just take 6 months to get it done, right? And because Bjarne was just giving us a C from 1.0, is a translator sitting on top of C compiler, not a big deal. Sun has a great C compiler and optimizer. And lo and behold, right, if you look at basically the history, it has been about 20 years journey. So basically the 6 months project turned into 12 months. Of course, I did a lot of explanation and I defended the C++ evolution, because the C from 1.0 doesn't really have a whole lot of capability that will really be empowering the application and the programming paradigm. So basically we moved to C from 1.1, C from 1.2, C from 1.3, then we got C from 2.0, and where we want to introduce multiple inheritance. Then we evolve into C from 3.0, where we want to introduce template. And all these are revolutionary features. And during the path, a lot of us were debating with Bjarne to argue that C++, in order for it to be really successful, it needs to have an open platform. One of the things is to put it in the NZ and the ISO standards, right? So now, 20 years later, I recently just checked in with Bjarne. He's still very gung-ho on this. And basically, you look at the evolution of all this. He has a very big dream. And he fundamentally believes in the robustness of this. But however, as he implement all this in this, he actually didn't rush to introduce all feature all in one shot. He actually learn, experiment, dabble, and learn and dabble and experiment and introduce the new things, right? Now that cycle does have its cost. For example, I originally planned to run my first Sun C++ beta with like your typical 6 to 8 weeks beta. It turns out that beta lasts for 18 months because we were very honest and transparent, and we listened to the people that are trying to adopt this early technology and the object-oriented programming paradigm. That was the breakthrough at that time. And we realized there is gap. So these innovation gap has to be fulfilled before it will become a very powerful proposition and before our dream can be robustly materialized. So basically that's the reason why the beta actually runs 18 months. It rooted from this simple request from Eric Schmitz to me, because I went to him because I wanted to be promoted to be a staff engineer. So I asked Eric, so what does it take for me to prove it to you that I am really worth the promotion? And he basically said, you're doing this Sun C++ 1.0 release. You just need to make sure it's successful. So I asked him, so what is the success criteria? His answer back to me is very simple. You just need to have 100 customers send me email directly. All they need to say in the email is, I am happy. And I thought that was an easy job to do, but it took me 18 months to get those 100 email to Eric. And I did not bribe any one of them. So, and if I look at the VMware journey, it's the same thing. When Mendel and Diane started with the vision 26 years ago, they put the virtualization into the Webster dictionary and introduced the whole concept. Their very beginning use case was very modest. They just basically see there's a lot of waste on the compute servers and the storage, and people are putting it all into the inventory. They become like an unusable hardware. Reality is they can still be reused. So the virtualization made that possible and reduced the hardware cost and the data center operating costs. That was the beginning use case. And the introduction, it wasn't really the fancy software-defined data center and the virtualized network. It was actually the edge cloud. And it was basically on the desktop virtualization, the simplest use case. The killer feature of a vMotion that be able to move the workload was not introduced until maybe 4 or 5 years after the first release of the virtualization. So all this shows that you could dream very big. You can create very disruptive innovation, but the key is you have to think small in order to make a robust progress, right? So this is basically giving you a very simple example of both the C++ and virtualization, how they actually revolutionized the programming model and the data center scalability, and how do they target a persona, and how do they evolve. And basically, and then there are some fundamental portion, for example, the EXX, our hypervisor, that is the most robust piece. And it is the piece that's ongoing, just like the foundation for the house. For C++, a lot of that is the robust programming design, right? And so basically for here, I just want to share with you a very simple innovator dilemma in terms of how do you introduce a disruptive innovation that will really last. There is no trade secret, and it sounds like a cliche, but the most important thing is you have to basically make them work together. Each of the technology is robust, and many of them will be off the shelf and basically being very well proven. And even the artificial intelligence that we all touted about nowadays, that is in the computer science field for more than 2-3 decades. So how do you take all these robust and reliable technology and basically integrate it together with the most imaginative use case that you reimagine that actually can bring benefit to the human race, to the society, to the computer, and to basically how human and machine interacts, right? And that's basically the disruptive innovation. And another very important thing is do not make yourself the enemy, because only you will create the biggest innovation gap. Think about the Kodak, right? Kodak used to be the most important camera technology and the vision technology. Unfortunately, they sit on their laurel. They basically didn't think the competitor would really kill them. So the reality is they had an innovation gap because they sit on complacency. So really the key in short is think big, dream big is a good thing. However, in order to make it disruptive technology and innovation last, you have to basically dream big and think small. And basically making sure that you do not get scared away and only be interested in new things only. If somebody asks you to modernize the code base or renovate the legacy system, that itself can be a very big project. You need to turn that into the dream big and decompose basically the think small steps in order to make it a successful. So this picture here, one is the Volkswagen, And when Volkswagen was introduced, right, that was the time everybody wants muscle cars. Nobody wants a small car. But Volkswagen come up with the Beetles and basically has this ad that is basically the most impactful ad in the past century. Basically, it's called Think Small. And it indeed is basically the biggest innovation in terms of the messaging and the execution aspect. And the other picture over here is actually, believe it or not, is the vSphere with the Kubernetes, right? vSphere has been around for 26 years. It's more than 25 years old. However, it doesn't mean the code cannot be modernized. It doesn't mean the code cannot be integrated with the brand new concept, such as the Kubernetes platform. So with that, I want to also recommend two good readings. One is basically called Think Small and the surprising simple way to reach the big goal. The other one is from Tom Peters, basically called Reimagine. So I highly encourage that if you have chance to basically follow through with these two books, even though they won't teach you programming language or coding or testing methodology, but these two books really help the technologists and the people that need to make their technology not die at the go-to-market point, right? You may have the greatest idea, but if the go-to-market step and the marketing and the communication and the execution fail, then your technology, your innovation will never see the daylight. So it's very important to reimagine and also to dream big, think small at the same time, to hold the disruptive innovation in a continuous momentum that will actually last. So thank you very much. So back to you.
Hey, Lily, it was an amazing keynote. Thank you so much for sharing and inspiring us. I particularly liked the dream big and think small. I can really relate to that. I'm sure this has inspired many. So thank you so much for that. Thank you. And just to summarize, what were the key learnings from this session is, I have, you said innovation is messy and it's dynamic. So we need to expect the unexpected. And it means that, we have to embrace messiness for the discoveries to happen. So, just accept it. So that's one point. And the second is technologies are robust. So, they're always there. The key is, we need to reimagine the use cases and apply these technologies. And the third one is dream big, think small, innovate continuously. Don't, get complacent. You keep constantly, reinventing. And if you do a disruptive innovation and work on the principles of disruptive innovation, it just works. We will get there. So those were the key takeaways for me. So thank you, Lily. It has been a wonderful, inspiring session for us. You have a great evening. Thank you so much.